My name is Lindsay Lauren Visser, and I am the very, very new Executive Director here at the Niagara Aerospace Museum. And I am so excited that I was able to join the organization just in time to welcome NASA to Niagara Falls and to our museum to talk to you about the upcoming solar eclipse. So today we have one of our amazing subject matter experts, but before I turn things over to him, I do just want to kind of say a couple things about the museum. The first is that we're so thrilled that you're here. We hope you've had a bit of a chance to look around the museum. If you haven't, we have docents here who will be happy to give you a guided tour. If you are interested in a guided docent tour, I'm going to ask you to, at the end of the talk, go up the ramp and kind of hang out in the gift shop. We'll grab people from there to go ahead and start the tour. Now, there's also a strategic reason to have you go hang out in the gift shop. Can't imagine what that would be. But we do have quite a few great special souvenirs that are NASA related or related to aerospace in Western New York. If you have not checked them out already, we have a really great challenge coin that shows the path of totality on one side, and on the back it's got some more really cool imagery. We have a really cool postcard that when you hold it up, you can actually do the eclipse. Very cool stuff. So you want to check out our gift shop for sure. Last but not least, on your way to the gift shop, we really thought through this. You're going to pass the membership table. And I would really hope that you guys would consider stopping by the membership table and checking it out, because we are the only organization in the area that really tells the story of the contributions to the aerospace and space exploration and aviation in Western New York. And we've had so many people here today who had family members who worked at Bell, or were riveters during World War II, or have some kind of special familial connection to this industry. And it is so important to our region. And that is why our organization is so important. And your membership really does ensure that we can continue to preserve and promote that history. So please, please, please consider joining with a membership today. They are $5 off if you do it over the course of the weekend. So please consider doing that. Now, I'm going to turn things over to Akash Vangani, who is the Chief Engineer at NASA Launch Services Program based out of the Kennedy Space Center, and he is actually going to tell you a little bit more about his background as well. So please join me in welcoming Akash, and we're so glad you're here.
Thank you. So I always do things a little bit differently, so we're going to start with a video. And then I'll get into it after that. So let's see if we can get that started here. So does anyone still think science is boring? That wasn't a Taylor Swift concert, that was a landing, but the excitement was crazy. It was real. So that was the first landing for SpaceX back in 2015, and that was a game changer for the entire industry. So I'd like to start off with that. Let's see here. Oh wait, I want to go to the next slide. There we go. So once again, my name is Akash Vangani. I'm the Deputy Chief Engineer for the Launch Services Program. So a NASA engineer, I always put this in there because I'm not exactly sure who I'm going to present to. So what my friends think I do, they think, you know, I work for NASA, I must be an astronaut. I'm not an astronaut. I'm an engineer, so I got to keep educating my friends. What my parents think I do, they think I'm just in some crazy lab all day running calculations. My mom still tries to figure out why I can't fix her washing machine. I am not a washing machine repairman. I'm an engineer that works on rockets. What society thinks I do, I think, you know, people think I might be in a lab all day. Kids might think I'm zooming around the universe. No. I actually put this last one, what I think I do. This is more of kind of an entertaining thing. I got to work on a really cool mission. I was the chief engineer for the DART mission, which occurred 2 years ago. DART was really cool because we took a satellite out to an asteroid and we moved it out of the way. And that was a really cool demonstration test to save our planet in the eventual case an asteroid came to our planet. We have the technology to move an asteroid out of the way. So that was a really cool thing. And we all got patches that said we're planetary defenders. So that's what I think I do. I save the world. And what I actually do is I am a chief engineer for NASA, and my job is to make sure that rockets work. So I work at Kennedy Space Center. My job is to make sure that the spacecraft that we are going to launch are going to make it successfully into orbit. So that's my number one goal. So, and these spacecraft gather information about the Earth, the Moon, the Sun, and they travel to other planets and to the edge of the universe, trying to get us to understand what's going on out there. So that's my mission. And one of the coolest parts of my job is I give the final go or no go for the engineering team. So all the engineering team reports up through me, and I go ahead and I get to represent them and give the go for launch. What is NASA? National Aeronautics and Space Administration. And really our goal is to inspire humans to explore, learn, and build a better future. Real straightforward. Go to the next video here.
Since the dawn of humanity, we've looked at the stars and dreamed of bridging the gap between the Earth and the cosmos. In the 20th century, NASA turned that dream into a reality by launching humanity into a bold era of scientific discovery. As pioneers of space travel, our best and brightest designed and built everything from the ground up, from launch pads to rockets, all of which were government-owned and operated. As NASA's science and robotics evolved, we encouraged the competitive launch market to develop, ushering in a new way to explore and discover through commercial spaceflight. Spacecraft customers from around the world, all with the same desire, reached out to find an expert at NASA for support. Thus, NASA's Launch Services Program was born. Our mission is to centralize NASA's launch services and address state-of-the-art customer needs when placing their spacecraft in orbit around the Earth, the Sun, or destinations deeper into the solar system. The LSP family is made up of a diverse tapestry of government and contractor engineers, analysts, operation experts, and business advisors, all united by a common goal: to get your spacecraft off the ground on time, on budget, and successfully to its final destination, wherever that may be. We match scientific and robotic spacecraft with the appropriate rocket and certify rocket performance and reliability. We support full-service missions, advisory services, and one-of-a-kind contracts. The Launch Services Program is the common thread that bridges the spacecraft organization to the rocket designer, and the spacecraft to the rocket. We provide long-term technical leadership and expertise from pre-mission planning to system verification and validation, all the way through physical by putting the necessary instruments in place. The thread that weaves NASA's industry-leading knowledge and support into the fabric of the commercial space market. We unite customers, capabilities, and culture to explore space through unparalleled launch services. NASA's Launch Services Program. We are Earth's bridge to space.
Okay, so this is a pretty cool slide. So our program was formed in 1998. So these are all the places that we've been. Our program, all the ones in green are primary missions for the Launch Services Program. And you can see there's a ton of satellites we've put around our planet. Then there's the moon, and you can see the different missions that we've sent to the moon. A whole bunch to Mars there, the red planet. A couple really cool ones. The one way up in the right corner was New Horizons. That went to Pluto. Took 9 years to get there, going over 40,000 miles per hour. So long ways away. Obviously the sun. And the ones in pink are actually advisory missions where we've partnered up with other agencies or even other foreign governments. A really cool one there on the far left is the James Webb Space Telescope, which was launched, bringing back some amazing pictures of the universe. Absolutely incredible. So we've been to a lot of places and explored a lot of the universe. Where we're going. So there's a lot on this slide. Once again, quite a bit of work around our planet. You can see on the far left is the Roman Space Telescope. That's going to launch in 2027. That's the follow-on to the James Webb Space Telescope. So even going to bring back more incredible pictures. I'm really excited about Europa Clipper, which is going to the moon of Jupiter. That's going to be my mission. I'll be launching that in October of this year. So we're getting really close. So that's, yeah, October is very close for me. And then a couple missions to Mars, as well as a whole bunch of advisory missions here. You can see in pink, they're going to the moon. And so we're supporting those missions, and that's in support of getting humans back on the moon. So a lot of cool missions coming up over the next several years. So why rockets? Major League Fastball, 95 miles per hour. NASCAR, I'm from Florida, so I have to put that in there, 200 miles per hour. You got to relate to things. So that relates to the folks definitely in Florida. Supersonic jet, 1,000 miles per hour, and you can see a bullet. The escape velocity for Earth, 25,000 miles per hour. So we really need to get moving to get out off this planet. And so our multi-stage rockets, 34,000 miles per hour, and you can see some of the spacecraft going up to 46,000 miles per hour. So with that, it still takes quite a long time to get to some of these other planets. Just to go to Mars, it's 7 months going at that speed. So pretty remarkable, some of the work that we're doing out there in the universe.
What's the right rocket to launch a robot? Rockets come in lots of shapes and sizes. So what's the right rocket for a space exploring robot? Choosing a rocket depends on 3 things. How much the robot weighs, how far away it's going, and what it's going to do. When the robot is small and light and stays close to the Earth, a small rocket is A-OK. When the robot is large and heavy, with lots and lots of gear, and travels far away in the solar system, a big, powerful rocket is what will do the job. It's hard to find the perfect match, but that's the mission of all the dedicated people in NASA's Launch Services Program. They've launched more than 200 rocket robot combos, connecting us all to discovery in the universe.
So that is the current fleet of our rockets right now. So there, you can see on the far left is the small Pegasus rocket, and I'll show you a great video coming. That rocket's very unique because it actually sits on the underside of an L-1011 aircraft and gets launched off an aircraft which can be basically anywhere in the world. So it's not at a launch site. So definitely show you some videos there. The rocket that we used quite a bit over the past several years was the Atlas V. We're not going to be using that rocket anymore because ULA is now going over to the Vulcan, which just had its first launch this year. And then we use quite a few Falcon 9 rockets and the Falcon Heavy. So that's mostly what our program has been using over the past few years. And then we're still waiting for the New Glenn to come on board. So that's our current stable of rockets that we get to choose from at this point. So launch vehicle hardware. The reason I put this here is I wanted to sort of show you what a rocket's made of. So at the very bottom of a rocket are the engines. You can see, like on the Atlas V, there's the RD-180 engine and the RS-27 for a Delta II. So engines at the base of the vehicle. If you go up all the way up to 2/3 of the vehicle is all fuel. So it's typically liquid oxygen and RP1, which is a refined kerosene. So it's basically all fuel up there. Once you start getting up towards the top of the rocket, that's where the brains of the rocket is. The flight computer, all of the avionics and electrical hardware there. So when the rocket needs to separate, the flight computer tells it that's, you know, to go ahead and start separating, where to fly, how to fly, that's all up there. The spacecraft, which is what we're responsible for, is up at the very top of the rocket, and there's a fairing that goes around the spacecraft during ascent to make sure that there's no damage to our spacecraft when we're trying to get out of the Earth's atmosphere. So most rockets are sort of built that way, mostly a lot of fuel, and then you get the avionics and our payload. So what's on these rockets going into space? Each rocket carries one or more payload. Typically for our missions, there's one payload per vehicle because most of our payloads are pretty large. Earth observing satellites, weather and hurricane tracking satellites. Super important for us in Florida to get those hurricane tracking satellites. Not so much up here in this area, but a lot of weather satellites. And then a lot of science probes, including the Mars rovers. That's what our program has done, is launch those Mars rovers. Missions to Jupiter, Pluto, pretty much anywhere in the solar system. And so that's what goes on the rockets. Satellites, they come in all shapes and sizes. I love to put this in there because kids look at it and go, look, it looks like a disco ball. But yeah, they can come in all different shapes. This was actually a very small satellite. It looks much bigger in this picture. But this actually flew on a Pegasus rocket, which is the smallest rocket in our fleet. And let me go ahead and show you. So the Pegasus, like I said, it goes underneath an aircraft, and I'll show you a video on how that gets deployed. But it's only 57 feet long, and it can hold about 1,000 pounds or 2 alligators. Once again, I'm from Florida. I set this up, so I'll try to relate to you guys. 3 Bills offensive linemen can go in there. Hopefully that works. That's always pretty cool to see a rocket dropping off of an airplane. So
That was a rocket dropping off the airplane.
yep, that was a rocket dropping off of an airplane. Let's see. So some of the Pegasus missions related to the sun, U-Star and Iris. You can see some of the pictures that came back off of those spacecraft. It's really, really cool to see some of these I got some great pictures coming up of a mission called SDO and Parker Solar Probe that also went out to the sun, but got much closer. So the Delta II, this is, I gotta say, this is my favorite rocket because I actually started working on Delta II many, many years ago. 1997 is when I started on that. Really cool rocket. We call this the workhorse for our program. We probably launched over 100 missions just on this rocket. Super reliable, great vehicle, and about 10,000 pounds. I don't know why I put hippos there, but it just, they added up to 10,000 pounds. So I don't know. You know, a lot of offensive linemen. Let's just put it that way. Let's see. So I'm going to talk through this. So this is an animation of the Delta II that launched MER-A, which was one of the Mars exploration rovers back in 2003. So you're going to see the animation, and you know the rocket part's great, but what I really want to convey in this is towards the end of the mission with the spacecraft. So this spacecraft was about the size of a golf cart, and we had to land that golf cart on the planet Mars, right? So we have about 1,000-pound golf cart going 45,000 miles per hour, and we got to land it gently, not to go ahead and break it. And so there's no textbook, there's no magic formula that says this is how you're going to do it. It's a lot of creative work and a lot of testing and a lot of failure, going back and forth, trying to figure out, hey, how are we going to go ahead and get this to land? And the way they came up with this solution, I thought was just absolutely incredible. It took like a whole bunch of imagination. It wasn't engineering at first, it was imagination. And then they went ahead and put the engineering principles behind it. So you'll see that here in about another minute. But yeah, that's sort of the rocket doing its thing.
It breaks up a lot of stuff, right?
Yep.
A lot of, yeah, it breaks up a lot of parts.
Yep. So this is all still part of the rocket doing its thing. That was a payload fairing that was housing the rocket. This rocket had a third stage on it, so needed an additional kick to get to Mars. So they're trying to spin stabilize the satellite, and it's on its way. And now it's just the satellite on its own. So, and you'll see a sign here that says about 7 months later in just a second. It fast forwards, I promise. There it is. And so, yep, here we go. So heading towards Mars. The very front of that is a heat shield. So that's the first thing, is to make sure that they can go ahead and make sure it doesn't burn up. Oh, just a minute, as soon as the slide finishes. They call this 7 minutes of terror for the engineers that are sitting here watching this, hoping that this survives. So parachute, great way to slow something down, but this is where it gets really, what I think, genius and a lot of imagination. Yeah, bubble wrap, airbags. Then they have some retro rockets to try to slow this down even further. There is a very, very expensive and delicate rover in there, I promise. So that's why it's called 7 minutes of terror, because now they got to wait for this thing to open up, and hopefully it works. So a lot of testing occurred on the ground here to make sure that this was going to work. So those two rovers back in 2003 lasted much longer than they were anticipated. I mean, I think one just finally quit a couple years ago. So Really amazing work by the JPL team that built this spacecraft. So, but once again, I love the imagination that went into it, coming up with a solution. I mean, there was no textbook that says this is how you're going to land something on Mars. As we get forward into the presentation, there's going to be another little picture of Mars Science Lab, which was a much bigger spacecraft that they tried to land on Mars that was successful. Totally different landing concept because this would not have worked. So the Atlas, this was a vehicle that we used for several really important missions and can house the size of a school bus. So it's a ton of capability.
4, go from ignition, start, 3, 2, 1, 0. And ignition and liftoff of the Atlas V with the Solar Dynamics Observatory, learning why our star is changing our lives.
So this Atlas mission, I was an assistant chief engineer back then when this occurred, and so this was a real special mission for me. This one actually went to the sun and took some incredible pictures, and I'll show you those on the next slide, and why this one has a special place in my heart. So, so yeah, Atlas V mission. So SDO. I love this picture up here on the left. It came back, so my daughter at the time was probably about 6 years old, and she used to draw pictures like most of the kids do here, right? A nice round yellow sun with some lines coming off as solar, rays. That's what a ray looks like. And showing her that picture, it changed, it just changed how she looked at the sun. And in future pictures, she started drawing things like that. And my wife's like, don't do that anymore. So, she's like, the sun looks angry. No, it's absolutely incredible. So I absolutely just love that picture, and especially when you can go ahead and change how a kid sees how the universe is. That's really amazing to me. I was also worked Juno and MSL. MSL was a much bigger rover, about the size of a very small compact car. They had to use what they called a sky crane to go ahead and drop that gently onto Mars, which was another super imaginative way to go ahead and land something that large on Mars. And that was also a very successful mission. Then there's the Delta IV. This is the big boy. This one can launch about 4 trucks, 37,000 pounds. The last Delta IV Heavy is scheduled for this Monday. It's going to be launching at Cape Canaveral, so super excited to see that one go. And so Parker Solar Probe, our program launched that Delta IV mission. So the sun is 93 million miles away. We got to 4.5 million miles away with Parker Solar Probe for this picture, which is absolutely incredible to get that close to the sun. So the pictures that it's brought back are just, mind-boggling, when you can get that close to the sun. So I should probably talk about the eclipse, right? Why most people are here. So what is the total solar eclipse? Basically, it's when the moon gets between the Earth and the sun, and we get the shadow cast on the Earth. And you can see that over in the right-hand picture there. And totality is, well, I just missed that part of the animation on the picture on the left, but basically when the moon covers up the sun. So there's the path. We're definitely in the right spot, which is a good thing. I was lucky enough to see this in 2017, the last time it was in the United States. It passed over Charleston, South Carolina, and I was there for that, and it's absolutely amazing. I'm really hoping the weather cooperates on Monday, so hopefully we'll get a great view of that. People ask, why is this year so special? What's different? There's totality, eclipse with totality every year. It's just, this is going to be in the United States, and the next one in the United States is going to be 20 years from now when it all lines up. So you can go to other places on the planet and see the eclipse, but you just won't be able to see it here for the next 20 years. So super special this year. I'm almost done, and then I'll answer all your questions, I promise. So safety. got a funny story about this. So back when I was probably 4 or 5 years old, my parents took me to India, and there was a total eclipse there. And you know, back then there was obviously no internet. This is way back in the late 70s, early 80s. So no internet, and we all had to go into the bathroom and make total darkness in the bathroom. And I was like, why? And they said, if you're outside, you're going to go blind. And I'm like, so is all of India in the bathroom right now? And my parents said, stop asking questions and just stay here in the bathroom. But that's how they looked at it. They just didn't know, and that word wasn't spread. So, yeah, you can be outside. You're not going to go blind. But what happens is it's not safe to look at the sun. And that's not just on the day of the eclipse. That's any day of the year. You don't look at the sun. Even with sunglasses on, right? It's going to hurt your eyes. So these special glasses, because everyone knows the eclipse is coming, everyone's going to try to look up. That's why you need to wear those glasses. You do not want to hurt your eyes. So while the moon and the sun are lining up, you know, you can safely look at it through glasses. Make sure the glasses that you have are real. They should have an ISO standard on the glasses, so you know that they're not fake, that you didn't buy a cheap pair somewhere. I know NASA's giving them out all over the place, so hopefully you can just get a pair. And then once we're in totality, right, for those 3 or 4 minutes, it's safe to go ahead and take off the glasses and look, and then as soon as we're out of totality, you put your glasses back on. So very important not to look at the sun without these glasses.
Are there any natural sunglasses that you can use, like polarized?
No, nope, absolutely not. So people might claim it, but you have to have some ISO certified glasses to wear. Otherwise, you will hurt your eyes. Let's see. So there's the total eclipse, and you can see the partial eclipse. So the only safe time to go ahead and take your glasses off is during total eclipse, where it says no filter in the center there. All other times you should be wearing those special safety glasses. Indirect viewing methods, I'm going to skip over that. So heliophysics, which is a division of NASA, huge year for them. This year, a lot of great science coming out. So the annual solar eclipse was October 14th. The total solar eclipse is obviously this coming Monday. And the closest approach point for Parker Solar Probe is going to be December 24th. So that'll be the closest it can get to the sun this year. And there's the solar minimum and the solar maximum. So we get the highest solar flare activity over with the maximum. So just another, the amazing pictures and stuff that we get back from these satellites is just remarkable. And if you want to learn more about the solar eclipse, there's a bunch of QR codes that you can scan there. So with that, I know there's someone here that wants to ask me a lot of questions. So I'll let you start.
I know about the parachute and the rover, and that's the biggest car, and they use those satellites to make electricity. And I know
Oh, I think you're definitely ready for an internship at NASA. So a few more years and you could definitely come work on some rovers for us. Good.
What's an intersolar banter?
What?
What's an intersolar something?
I don't know what that is.
Mm-hmm.
He said intersolar something.
Oh, an intern at NASA? It's basically a student that wants to come and work with us, and then eventually, hopefully, get a job with us one day. So we take interns typically in high school and in college. So
That's a good question.
How did they make the heat resistant make on camera, the thing that was watching the sun? How do they have a heat resistance on it so it doesn't get burned?
So that is a lot of work with materials. So there's a whole division at NASA that goes ahead and makes heat shields. And so there's special materials and coatings to basically absorb and deflect the heat that's coming on. So we have those actually, if you remember the space shuttle, the whole bottom side of that space shuttle was all specialized heat tiles and shields. So There's groups that are called material and process engineers that sit there, develop materials like that, and then they go ahead and test them. They put heat guns up and try to burn holes through these materials on the ground, so when they go ahead and use them in space, they're actually going to work.
When the one that orbited around the sun, when it got that close to the sun, did it burn up or did it not?
Nope, it was still far enough away from the sun, and the protective materials around it kept it working, and it's still working right now. And we're going to get a picture back in December of this year. So yeah, it did not burn up. It's still far enough away that it didn't burn up. But if it got any closer, it probably would.
How much closer are you hoping to get?
I don't know the answer to that. I'm definitely not a scientist per se. My pure job is to make sure that the rocket works and to get that satellite into orbit. So our program's a little bit unique since we don't build the rockets, right? We have commercial companies that build the rockets for us. Our satellites are one of a kind, right? Some of the commercial satellites, they're probably hundreds of thousands of dollars, and you can replace them and you can replace whatever they need to do. The technology that we have, and like a rover, those are very expensive, and you cannot replace them. They take on the order 10, 15 years to build those. There's some of our satellites that, we're in the making for 25 or 30 years. An entire scientist's life work. One mission like that was Gravity Probe B that I took about 30 years into development, and it was the principal investigator. That was his baby from day one to the end, and so we have to make sure, right? Yeah, we have to make sure that works because there is no replacing that work, and so no one would ever insure one of these vehicles, right? For some satellites, you can get insurance. You cannot get insurance for our rockets, and so I am that insurance, right? My team's sole goal is to review every piece of engineering, review all the issues that have come up when you build a particular rocket, make sure it's going to get to the right spot safely, and that's what my entire team does. Let's go over here.
Thank you very much for the yummy presentation. And I think I'm ready to be an intern.
So when you guys are ready to be interns, USA Jobs is a great place, and then NASA.gov. I highly recommend you go there, and you can find all sorts of opportunities. There's also opportunities to go ahead and do science. At your age, you can go find things, and there's different challenges that you can go ahead and try doing. So NASA.gov is a great place to start. And when you're ready, we're always looking for internships, and we're always looking for engineers. And I should probably also say this, because I always get that question, right? We're not just engineers. We have an entire business office. We have lawyers, right, that work for NASA to make sure I don't get in trouble. We have doctors, right, that work with the astronauts to make sure that they're prepared and go to space. There's all sorts of folks that work at NASA, not just engineers. I just happen to be an engineer, and I love talking about engineering, so that's what I'm here. But we have plenty of business folks and contracts folks, and so it's a huge thing. So even if you're not into science, but you should be, even if you're not, there's other opportunities at NASA for you. Go ahead.
About rovers, I want to show that there was a rover on Mars, and then a giant alien just come down of the ground and crushed it.
Wow, I'm glad I missed that episode.
So I noticed you guys, I think it was called the Phoenix that launched off the aircraft, right?
The Pegasus, yeah.
Pegasus, okay.
Yeah.
So what's preventing more of that kind of technology? When is that appropriate to launch off a plane versus rocket?
Yeah.
What is the middle gray area?
So a huge advantage of launching off of a plane is you can do it anywhere in the world, right? So some of these bigger rockets, there's a lot of infrastructure that goes into it. So our rockets launch either from Kennedy Space Center, Cape Canaveral in Florida, Vandenberg Air Force Base, which is in central California, just near Santa Barbara, Kodiak, Alaska, and Wallops Island in Virginia. So those are the 4 main bases in the United States. All of those have the same common thing. You're launching over water. We can never launch over land for safety concerns, right? You definitely, if there's an accident, you don't want that to happen over land. With the Pegasus, right, you can take off from any airport in the world, get to a high enough altitude over water once again, and deploy. So you have a lot more options. The challenge is with the small spacecraft is they're small because they have to fit under an aircraft, and there's some, weight limits and everything else. Satellites are not getting any smaller, and so it's a very limited market for that type of vehicle. That being said, so that particular Pegasus, they don't have any more. They have one more left that they're going to launch later this year. Virgin Orbit was trying to go ahead and do this, and they actually had their first launch out of London. They ended up launching there. Unfortunately, it was not successful, and that was the end of that program. So there's currently no launch vehicles that are going off planes anymore. I'm not sure if anyone's ever going to develop another one, but that's the only limitation. So pluses and minuses to it. Size, but it's great that you can launch anywhere in the world. So that helps with performance, right? You can launch and you don't need as much fuel if you're launching, let's just say, out of the South Pacific versus launching from here and trying to get to the South Pacific. So, all right, let's start here and then go around that way.
Is there any kind of a governing body that determines where satellites should be? I mean, there's an awful lot of satellites flying up there from a lot of different countries.
Absolutely. So the FAA is one that governs, and they actually provide the licenses for these launches. So they're responsible for understanding what payloads are going on these and where those payloads are going. So all of those are FAA licensed launches. The bigger thing is, right, FAA is here in the United States. Every country, right, so the Europeans launch the Ariane, Indians are launching their rocket, the Chinese launch, the Russians launch. Everyone has to declare where they're putting their satellites, because we definitely do not want to launch and hit one of their satellites or run into it. So everyone knows where these satellites are, and there are governing bodies to make sure that they go there. But it is a huge problem also with all the satellites that are up there, because satellites do have a limited life, and they end up running their course after a few years, and then at that point they're junk. And so hopefully they come back controlled and just burn up before they come into the atmosphere. But there is a lot of space junk out there, and there's actually a lot of companies right now that are trying to go ahead and develop a solution to remove that space junk, because it is becoming a problem, and especially for astronomers trying to look up at stars. Next thing you know, they're seeing a lot of satellites which just weren't there. And the evolution of commercial space with companies like SpaceX launching all their satellites all the time, it's great because it really helps a lot of the folks here. I know their Starlinks have been used for our fighters in Ukraine and all around the world. So it's a great resource, but there is the negative that there is a lot of space junk up there.
My question was about when you are going to get those pictures back on the 24th. Do you get real-time images, and how do you transmit that real-time image all the way to where you are from there?
Yeah. So there is called the DSN. We love acronyms at NASA, by the way. The Deep Space Network. And so it gets transmitted through a series of relay satellites back here. So once it takes that picture, it's on the order of a couple hours before we get them back here and processed. Yeah, so like especially when we launch something way out there, like Pluto, right? Way out there. It had to relay all of those signals back through that deep space network to get back here. So satellites that are positioned out there across the universe.
And then the quality is that good then?
Yeah, it's just amazing. If you ever get a chance, go look up JWST, the James Webb Space Telescope. The pictures that have come back from there are they're mind-boggling. It's so impressive to see what's out there and realize how small our planet is versus the rest of the universe. It's just amazing.
What's the first spaceship that was ever made?
The first spaceship that's ever made. So, um, I think I'm gonna start. My answer, my guess, right? I'm not a historian, but I would say one that really got everything sort of started was Sputnik, believe it or not. So Sputnik was a Russian spacecraft that orbited the Earth, and it basically was just pinging back to Russia, but it actually ended up scaring the entire world, and that sort of led the United States to go ahead and really develop a space program and get us to the moon. So, yeah, I'd say Sputnik was the first spacecraft that did that.
I noticed that the Delta IV is on hydrogen and oxygen liquid, and that's like a transfer away from fossil fuels, obviously. And have you made any progress? Is it on your guys' attention for maybe refueling with ice belts, asteroid belts, mining belts, since it's already out of the atmosphere?
So, propulsion technology is definitely a challenge here because it's so much, it costs a lot to develop. And so right now the big push, believe it or not, is methane, is what a lot of the companies are sort of going to as a future for future rockets. Yeah, it's sort of headed in that direction. I think you're going to see the next set of big rockets go that way. Yeah, yes.
Okay.
So, yep, so that's the plan. But yeah, propulsion is always the biggest challenge, is finding that source. And things are getting very, very expensive, especially with helium and some of the other things that we end up using. So methane is sort of where I think this is going to go in the future.
I have one more question, I'm so sorry. The
Sure.
Mars lander that you guys dropped, you dropped a propulsion craft and just test out flight in the Mars atmosphere?
Okay, sorry, can you repeat that? Sorry.
One of the Mars landers that was dropped recently, they released a little propulsion vehicle, a copter of some kind, just to test out flight in the Mars atmosphere.
Yep.
Did that, I doubt it because you're building rockets to go up, but did that teach you anything about what you do? Did it give you any big insights how a copter would actually operate in the Mars atmosphere?
Yeah, believe it or not, we've been doing that for quite a while with several of our spacecraft. We do have small, smaller satellites within the belly of these spacecraft that actually, to get deployed, go around and then actually, send video back to us of what actually occurred. So that was, with the Mars, we did that. There was a mission to the moon a few years ago called LRO L-Cross, where L-Cross was an impactor that actually hit the moon, and they had LRO, which was the Lunar Reconnaissance Orbiter, that actually filmed the whole thing and was able to actually capture some of the debris that came out after the impact. So, really cool mission. There's been other, small satellites, a lot of them made by foreign partners like the Italians, that have a small spacecraft that's going to videotape what actions with the big spacecraft. So it's pretty neat that way.
He wants to know what's going to be more expensive to build the lunar space station. This could be more than the International Space Station was.
The question was, is the lunar space station, the gateway, going to be more expensive than the ISS, the International Space Station? Yes, it's going to be much more expensive. I think every parent in here will tell you things have always gotten more expensive and not cheaper. So, and that goes for everything that we build. It's going to be a very large space station, the Deep Space Gateway. So,
What kind of engineering do you support NASA?
can you say that again? I'm sorry.
What kind of engineering do you support NASA?
So that's a good question. I studied aerospace engineering in college, and I also got my master's in aerospace engineering. When I started at NASA, I started with structural engineering. So I did that for probably 4 or 5 years. Then I switched into integration engineering, so basically making sure that a spacecraft would fit on top of a rocket. I did that for a couple years. Then I did ordnance, which is basically the explosives that we use. So did some ordnance engineering for a couple years. Then I went into systems engineering, and so basically responsible for all the hardware on the rocket. and now I'm a chief engineer, which makes me responsible for all the hardware and the analysis. So, um, you know, I've done a lot of different things over the years. I enjoy. I'm not one that likes to do the same thing over and over again, and so I love learning about new things. So whenever an opportunity comes up, I'm the first person that raises their hand and says, "I'll try that," which is why I ended up with so many different jobs. And then I finally got into a job where I get to do a little bit of everything. So, great advice for anyone that wants to be an engineer or basically anything. Whenever you get an opportunity at work, take it. You're always going to learn something, and if you put all your effort into it, only good things will happen. So definitely encourage you to do that in the future. I probably can't give you a great answer. Yeah, I don't know. I'm starting to get encouraged by the weather. It said it was going to look really bad, but I think it's starting to get a little bit better. So hope. Yeah. Well, you know, the big. Oh yeah, it'll definitely be on everywhere. But you know, I think Texas was one of the big locations, and a lot of folks went there. The weather's even worse there. There's supposed to be thunderstorms all day, so we just sort of have to hope to get lucky here. So, yeah, I can't control the weather. I wish I could, because I wouldn't be here. It's so
Not yet.
cold. It is so cold here.
It's a total non sequitur, but what did your daughter end up doing?
So my oldest daughter wants to be a doctor. She's in her second year of college at UCF. And my younger daughter is going to be a freshman in college and will get a business degree. So my youngest wanted nothing to do with math, and same with my oldest. They take after my wife in that regard. So I'm the math guy. I've always loved math, and I've always loved breaking things and putting things back together. So it's sort of natural for me, and I'm a big fan of science and engineering. So it's a great career. I grew up in Detroit, so I wasn't in Florida my whole life. So I grew up in Detroit, moved to Los Angeles when I was like 15 years old. But I'll tell you, my first trip to Florida and going to see the visitor complex at Kennedy Space Center, so that's what I want to do the rest of my life, and that was at age 4. So I've said, hey, I've always wanted to be a part of this. And you can't ask for a better career, so in my opinion. Any final questions?
Before we wrap up, unless you have any other questions from the group?
Yeah.
No. Go ahead.
How many people work at, say, Kennedy Space Center? And what's the average age?
A lot. There's a lot of people that work at Kennedy. There's several programs and there's contractors. I can tell you we have one of the smaller programs, our launch services program.
How many people work under you?
So we have, our entire program is about 400, and out of that, I would say 250 are engineers, and then the rest have various roles, contracts, business office, sort of everyone else. But yeah, it's a pretty small team for all the missions. I mean, you saw the number of missions that are there. We're busy.
The SpaceX groups, it looked like, I assume that was a lot of engineers that worked on what they were all cheering about the landing and whatnot.
Yeah, so
And they all look very young.
Yeah.
So, I mean, that's goes well.
Yeah, so definitely SpaceX has done great hiring young. I'll tell you from the NASA side, we have a pretty good range of folks. I think we are starting to lose a lot of folks to retirement, but we have a lot of new engineers coming in. So I think we're pretty well balanced, and most folks that start with NASA stay with NASA because it is a great job, and we get treated really well. I would never say anything negative about it. We get treated super well we have the best agency in the government by far. SpaceX has definitely hired young, but they do have quite a few senior folks that have helped develop develop their team, and so yeah, the industry's changing. Kids are definitely getting a lot smarter. We see it with all our new hires too. I'm amazed every day with the kids. I was like, man, I wish I was that smart when I came in many years ago. So The kids are definitely getting smarter.
So, ready to go?
I think so.
How is space service, new branch space service linked with NASA, or is it, or?
Space service.
Space service, is there a new branch?
The Space Force?
Oh, the Space Force. Yeah, so it used to be the Air Force, right? The Air Force had a branch that ended up focusing on space. So they launched a ton of satellites called GPS, the Global Positioning System that they use for their needs, to protect our country. And so they ended up branching off from the Air Force and created the Space Force, which is dedicated to space. And so they do very similar work to what our agency does, but just for the defense, the area of defense. So, and we work with them very well, very closely, since we all use the same rockets and all have the same end goal, is to make sure our satellites get to where they need to be safely. So it's a great relationship and a partnering between us and that agency.
Anything else? Well,
Yeah, any last questions? All right.
I think that, first of all, let's say thank you very much for really appreciate you coming out and sharing your firsthand experience with us. It's really awesome. I'm Don Irwin. I'm the president of the board here at the Aerospace Museum. And I just want to leave you with a couple of tips for viewing the solar eclipse before you go. Some of you may have heard this, but first is, unless you're like a really hotshot photographer with a lot of great gear, don't try to spend a lot of time taking pictures of the totality. They're just not going to come out. If you hold your fingers at arm's length and pretend you're holding a shirt button, that's about how big the moon and sun will appear. In your camera, it won't look very well, especially for your iPhone or something like that. It won't look very good. So just take it in. It's an amazing thing. How many people have seen a total solar eclipse? Yeah. So you guys can probably all testify that it's a pretty amazing sight, right? You don't want to be looking down here when all the activity's going on up there, right? So that's the first thing. The second thing is, if you have a tripod or can just set your phone up somewhere, do video record your friends and family, the people you're with. We did that back in 2017, and we watch that all the time just to see everybody's reaction when they go, oh my goodness, what is that I'm seeing in the sky? It's crazy. And you will love it, especially if there's kids. Definitely try to record your friends and family and all that's going on, because that's the stuff you'll remember and watch. There's going to be a ton of professional pictures on the internet 2 minutes after it happens, right?
Oh,
You don't spend your time doing that. Really take it in the moment and then record your friends and family. Question, Mr. Red Hat.
Is it gonna be different than like when it's nighttime because it's not gonna have the sun reflecting off?
It's going to look pretty nighttime-y. So what you will, it's going to be like dusky. So if you're in a space that has a broad view of the horizon, you'll see sunset 360 degrees all the way around. So it won't be total darkness, but if the street lights normally come on at night, they'll come on. If you're a place where chickens crow during the night or when the sun comes up, that'll happen. Anything that happens during night is going to happen briefly, and then it'll be day again. Even if there's clouds, it'll get dark, and then it'll get a little lighter. Now, I was listening to this guy, I can't remember his name, he's a NASA expert's been to over 30 solar eclipses around the world. He said he was at one in Mongolia once, and there was a very thin, high layer of clouds, so they couldn't see the solar eclipse, but what they did see was the shadow of the moon rushing across the clouds, and that must have been really, really neat, right? So if you're in a high place that has, like if you can see the horizon, you may be able to see the shadow rushing at you at 1,100 miles an hour, which is pretty fast, and then rushing away at the same way. So those are the two tips I wanted to get to you. Don't try to take a picture. It won't come out that good unless you have really great gear. Secondly, take a video of the people that you're with. Question?
Remember a few years ago when they had the partial and they had all those beautiful crescents all over the place? Will there be any of that?
Yes. Anytime there's a partial solar eclipse, anything where the sun filters through, tree leaves, they showed a colander,
Yep.
anything, you'll see little crescents, right? That's the whole concept behind the cereal box pinhole camera, where you put a pinhole in it and you look away from the sun. It's the same thing. Anywhere there's you can just take your fingers and do this, and it'll make a little the shape of the taking the bite out of the sun. It's pretty cool.
There you go.
Yeah, if you have the opportunity. Yep, like these. You really can't see it from back there, but those are all little crescents. You know, it's really cool. Looking through the shade of a tree is really an awesome thing to do. So take the opportunity to do that. So what is it kids do when we're hoping for a snow day? They like, what do? You wear your pajamas inside out? Flush ice down the toilet?
Honey
Those
in the
things?
freezer.
Yeah. Whatever those things are that make the clouds go away and the sun come out, do those things, because we really want sun, right? Okay, any other rocket ship or solar eclipse questions?
If you gotta drive, if you're driving, what should you do as a precaution?
Just drive well and watch out for other. Yeah, so the sun isn't gonna, there's right before totality, things look a little polarized, the sun looks a little different, your shade of your skin's a little different, but it's just like, dusk into nighttime, all it happens really quickly. Just be careful of people who are driving and looking up. That's probably
But can you drive without just looking up, you just looking like?
Yeah, just, I wouldn't recommend it because you're gonna miss a once-in-a-lifetime opportunity, right? But, yeah, there's no need, you only have to fear nighttime, because that's all it is. It's just a brief nighttime, a dusk really. Nothing to fear. It's something to celebrate and enjoy. It only happens very seldom, so enjoy it. Okay, thank you very much everyone for coming.